Welcome again to the Southwest Climate Podcast. Mike Crimmins, how you doing?
Zack, how are you doing?
I'm okay.
Good.
Happy Friday.
Happy Friday.
Happy early November.
Oh man, it is so nice out. So nice out.
Mike, have you had coffee?
I not enough. Not
Not
enough.
enough. I'm
You're
sensitive.
you're looking you're looking a little ragged there.
Well,
You look beautiful as always, Zach, but a little on the ragged side.
I'm trying to actually I'm trying to go with the mullet,
It's actually
since I can't grow long hair in the front. I thought, maybe, my second act ought to have, a full-on mullet. What do you think?
hockey hair is always in style. Like it never goes out.
Was it ever in style? I didn't think the mullet
Well, I
was.
mean, it's in NHL, it's never gone out. So
I guess I don't watch hockey, but maybe I'd fit in. Yeah, I'm feeling good. I'm feeling good. You know what? So we talked about last time that this time of year is, I think October, I said it's starting to become like one of my favorite months. And I'm going to extend that to at least the first part of November.
yeah, I think it's unfortunate. It's like a climate change thing though, because it used to be early October was like you kind of snap into kind of the cooler, drier weather, and it's just like crept all the way into the end of October. And so I'm like, oh yeah, early November. This is pretty nice.
When I think the mosquitoes were finally beat back. I don't know about you, but like,
Oh,
are they still around for you?
they're in my garage. I don't even know how they've taken
They're
up.
still there? Yeah.
Yeah, yeah. I mean, I've kind of gone around the yard and tried to take care of any of the rainwater that has kind of hung on from some of that October rain. But yeah, they're still hanging in there. You know, what I heard too is that the drier it gets too, so that the dew points had continually dropped off. I'm so tuned into the dew points that even the mosquitoes start to dry out when it gets to be too dry and they can't hang on.
Oh,
So
so it's not
they
just
literally
it's
desiccate.
just not
Yeah.
just a temperature thing.
I think it's both. I think if it was a little bit more humid, then you'd also see the overnight temps be a little bit higher. But I think it is temps, but they can also desiccate more quickly.
Hmm. Well, it's beautiful. And you know what we don't have in November, early November?
No, I don't know.
Polar vortex.
Polar vortex. You mean it just hasn't taken over the news yet? Is that why?
Well, it has for the East, right?
Oh
Like,
yeah, I guess I hadn't really been paying attention. Yeah, yeah.
yep, yep, that's back. Like, apparently it's going to get really, really cold, and it's maybe even unprecedentedly cold for early November in the East. Anyway, we don't have that.
We do not. We do not. It is still quite lovely out. It's a little on the warm side as it's for this time of year, but we're losing the day length and stuff's starting to cool down.
All right, so we want to, I think we came, our last time that we did the podcast was early October. And so we'll recap October, look a little forward, do some hurricane summaries. Hurricane seasons are actually waning, right? Like the North Atlantic doesn't that end in the end of November, right? But the East Pacific is the end of October.
Right.
Yep. But for all intents and purposes, most of the hurricanes are in the rearview mirror, which is a good thing for a lot of people. We'll talk a little bit about the hurricanes, and then we've got a developing La Nina that's probably weakish.
This is very convincing.
But I guess I would say this to start. Like, I think there's a lot of pressure on rain and on precipitation this winter, right? We've had
Yeah.
sort of last winter was pretty dry for the most part in the Southwest, and then that was bracketed by two pretty dry monsoons. So we've had three seasonal seasonal rain that's been much below average. And with the La Nina on the horizon, which we'll talk about, doesn't bode well for this upcoming winter. So I think there's quite a bit of pressure on us in terms of drought and what that'll all bring.
Yeah. Yeah, for sure.
All right, so October. Um, we actually had a really interesting event in October, mid-October, I think around the 10th. Lot of rainfall, Mike. And it was, let's see, I think we'll talk a little bit about what the conditions were like. So on October 10th, looked like Las Vegas. So rain went all around the Southwest, kind of missed New Mexico for the most part. This one event, it was more like Arizona, north of Arizona, and into California, right? So Las Vegas had a record rainfall on the 10th of almost an inch. Phoenix on October 12th had close to 2 inches, which was the fourth wettest October day on record. Mesa, Arizona, there was a bunch of flooding on Mesa, closed US 60. Grand Junction during that period saw about 2 inches of rain, setting a daily record then. Tucson, boy, I don't even have Tucson up. Do you remember? Oh no, Tucson had like over a couple day period about 1.88 inches.
Yep.
Yeah, in fact, October for Phoenix was the third wettest on record. 97th percentile had three and a quarter inches. Flagstaff had like 3.5 inches. Tucson had close to 2 inches. All of these were, top 15 wettest on record, all from this one event, more or less, right? And this one event was interesting in that there were back-to-back. There was a Hurricane Priscilla that was moving up the West Coast, and it was followed by a tropical storm Raymond, right? And that sort of pushed moisture into the region. But then there was off the coast of California, there was a low pressure system, right? Do you remember this event?
Oh yeah, totally.
Am I getting it right?
Yeah, I thought it was octave. So there was Priscilla, and then Hurricane Octave was already waning and got drawn into the circulation of Priscilla. I could be wrong though. I didn't even know about
I'll look this up while you're talking
two.
about the because Raymond, yeah, I'll look it up while you're sort of describing the event.
Yeah, so it was weird too because it was the same thing that we talked about at the beginning of October when we had a lot of the really strange catch up rains we had and not catch up, not as the condiment, but catch up as in like we caught up at the end of the monsoon and it really wasn't monsoon precipitation. The pattern that we had in September with that, again, very transition like pattern with the low pressure off the California coast and that low pressure system kind of nudging in and trying to draw in moisture from the south. So that's what happened in late September. And that pattern persisted right into the beginning of October. California picked up some rain in the northern part of the state. And a couple of storm systems skirted right north of us at the beginning of the month. And we were in the right place at the right time with that East Pacific tropical storm activity still being quite active. Had a couple of pretty big tropical storms in the right spot. And as you said, Zach, real strong low pressure system dropped along the coast out of that trough and drew the remnants of Priscilla primarily, but some leftover tropical storm activity right up through Arizona, and then caught the northwest corner of New Mexico, and then went into that southwest corner of Colorado as well.
It was Priscilla.
Okay.
Yeah. So, what did you call it?
Yeah, Octave. Yeah. Was it?
So that was on September 28th. So that was before. So
Oh, okay.
Priscilla was between October 4 and October 10, and it sort of
Got it.
went up the
Yeah.
Pacific. Octave was more out further west.
Got it. Okay.
Yep. So Priscilla happened, and then it was followed by, and that became actually a category 2. and then it was followed by Raymond.
Got it. Okay. So
Which,
that got drawn up into the circulation as well.
right. I mean, if you look at the maps of that time for precipitable water, you can very much see how both of those storms sort of actually pushed in elevated water vapor into the southwest that stayed around for quite a bit of time. But the rainfall didn't fire off until it looked like that low pressure system moved onshore and created the dynamics that like was able to take advantage of the moist air.
Absolutely. Yeah. I mean that the flux of moisture. I mean, again, this is the kind of fall event that we would look for at the end of September. And occasionally in October, if those storms are still occurring across the East Pacific, and if you can get the placement of the trough in the right position. And I think what this had going for it was just abundant low-level tropical moisture and a very strong upper level low that was actually progressing inland and actually bringing those dynamics, dropping those lapse rates, making it really available for generating organized thunderstorms.
Yeah, it was pretty impressive.
The events that we talked about at the last podcast at the end of September were similar. And so
Yes.
this event was had a lot of the same kind of hallmarks. I think even had more moisture associated with it. And it was a multi-day event. So kind of as you noted that, we were seeing heavy precipitation occurring kind of on the 9th and 10th across. So the storms were already popping up as that moisture was flowing in. And that trough was still off to the west at that point, and the low hadn't even strengthened or dropped far enough south at that point. So we actually had 10th, 11th, 12th, 13th, and 14th were days where precipitation was occurring across the state. And some of those locations, and what I noticed when I was kind of going back over this analysis is that as the event unfolded, it was the northern part of the Southwest. So this is primarily northern Arizona. Ended up seeing the activity first, and it progressed. So kind of Flagstaff, Prescott area ended up having a couple of days of heavy rain. It moved to the Phoenix metro area, and then as the front moved forward and the dry air started to squeeze the moisture out from the west and then to the east, we here in southeast Arizona and parts of New Mexico started to see the heavy rain through that progression of the period. I was working at home on the 13th, and that was the day where we ended up having some thunderstorms form, and it rained for like 3 or 4 hours straight, and we ended up having the wash behind our house, which hadn't flowed all summer and doesn't flow every year, run bank full. And we dropped into the high 60s at that point too. So it was a really strange event.
Yeah, and to your point, I mean, looking at Phoenix, so Phoenix had 5 days in a row, beginning on the 9th, October
Yeah.
9th, of rainfall. So it was just a tenth of an inch on the 9th, and then it was a quarter of an inch on the 10th, nearly three-quarters of an inch on the 11th, close to 2 inches, 1.97 inches on the 12th, and then a quarter of an inch on the 13th. And the same sort of 5 day pattern happened in Flagstaff. I think Tucson only got 2 days of rain. But also to your point, like these 5 days in Phoenix produced more rainfall than the entire monsoon season for Phoenix. And that's including that one big event, really, which was the entirety of the monsoon for Phoenix in September.
Yeah, it was bonkers, right? I mean, so ended up having flash flooding in September with the kind of similar progression of events with an actual honest to goodness cold front with a low pressure system coming in and squeezing out moisture. And typically that's the end. Like you end up squeezing out the monsoon moisture, you have a full retreat. But that pattern's been here since last spring, trough off to the west, and then if there's moisture to the south, it's able to draw it up. I thought we were done, and so to see that evolve and actually get another kind of transition event in mid-October was pretty cool to see. It did cause more flash flooding though on some areas like Globe that did not need the insult to injury after they saw all the flooding in September.
Yeah, and just to put this in context, the climatology, so the average for October for much of the Southwest is if you go sort of south, just thinking about Arizona. So if you go sort of south of the Mogollon Rim and the higher elevations, it's at the lower deserts are anywhere between, well, anywhere less than, 3/4 of an inch. And as you sort of go toward the southwest corner, it gets even drier. And then the Mogollon Rim area up until, sort of north of Flagstaff, you're on the order of anywhere between 1 and 2.5 inches of rain on average. And then it goes down into like the precipitation falls off when you're in the lower Colorado River Valley, to, obviously less than that. So yeah, like much above average across the Southwest, across Arizona, much above average across Arizona. Like,
Yeah, there are volunteer observers who reported 3 and 4 day totals of over 6 inches
ugh,
with repeat storms and that was in the central part of the state. So, pretty weird.
right. And just like for Tucson, for those of us in Tucson, the mean over the period of record from 1950 is about 0.81 inches. And as I was looking this up, I came across something that was new to me. All right. So Mike, what is the minimum? How do I phrase this question? Have all months in Tucson experienced zero as the minimum? That's a bad way to phrase it, but so I didn't think about how I was going to ask this question. Maybe I'll just give it to you and not ask the question. So
Okay.
only July and August are months that have never experienced zero rainfall
At what station?
at the airport.
At Tucson.
Yep. The
Okay.
minimum has every other month has experienced zero rainfall.
That's interesting. I
Yeah.
wonder if that's the case across all the stations.
In
So
Oh,
Phoenix,
right. Like well,
yeah.
I mean, I guess a consistent feature of, the Southwest climate is that the monsoon happens.
I bet Phoenix has had zero.
Yeah, I bet Phoenix has
Yeah, Flagstaff, I bet Flagstaff has fewer. I mean, has more, no, has fewer months.
with zero.
Yeah, zero. I can't even
It's
say
not, it's
it.
not, it's not as easy to form that
No,
question.
it's not. Yeah, totally. And then I was thinking, like Albuquerque and El Paso would have slightly different. That's interesting. That's an interesting way to think about it. Yeah.
I guess I would have thought though that there would have been a zero in there for July for Tucson, but there hasn't, uh, and and there hasn't for August either. But every other month has
Yeah.
experienced zero.
That's interesting. Yeah. Uh-huh.
All right. All right. So, Mike, I'm going to ask you to do some mental statistics here. Do a mental, empirical, orthogonal function analysis. Can you do that?
Sure. Yes, absolutely. I do the eyeball regression all the time. So.
So I came up with this because I was remembering, I think one of my favorite memories is, I think early on when I was here, when I started at U of A working for Klimas, I went to one of your presentations and you're showing the scatter plot and you're like, my eyeball regression says there's been an increasing trend. And I'm like, well, I can do that.
See, it's not that hard.
That was a great memory.
Try to make statistics accessible.
My eyeball regression. Yeah, so do your eyeball principal, or no, your mental principal components analysis here. All right, so
Yeah. Yeah.
so October, what are the three common patterns or two common patterns that generate rainfall? Right. So
Okay.
so
Yeah.
in other words, like what we just experienced in mid-October, what we just spent all this time talking about, like, it had an influx of tropical storm moisture that was aided by this low pressure system off the West Coast that moved inland, right? Like, is that a common pattern? And what would be the other patterns that we might look for to generate rainfall?
Yeah. So I think the trough interacting with subtropical moisture is probably PC1.
The most
So yeah, it's the most common and it probably accounts for most of the variability. Probably the next one, which is probably more impactful, is still some kind of weak southwest flow, but a direct tropical storm hit, right? And so that would be where you actually have some kind of closed tropical circulation make it all the way into the southwest, and you could trace that back to things like so the flooding of record here in Tucson would have been 1983 with Hurricane Octave, and that I think would have been more its own sort of circulation and dynamics producing widespread heavy rainfall rather than the kind of interaction of some kind of like frontal dynamics and approaching trough with subtropical moisture. And this whole pattern too, well, okay, so PC1 with the approaching trough, I think that one probably favors Arizona a little bit more and can draw up moisture, I think, through the kind of the northwest corner, kind of like we saw.
Why
I
would
think
it favor Arizona more? Just because it's
just
low?
yeah, I think just by being able to draw in the subtropical moisture up, kind of using some of the same pathways of the monsoon and sort of drawing moisture up from the south, so the East Pacific up the Gulf of California, it's going to be a little more favorable. I think as those troughs move inland and they're kind of drawing from the south, sometimes that pipeline will get cut off for parts of New Mexico.
Mm.
Sometimes it'll actually enhance that because it picks up some moisture further to the east. I would think then a third component, which really leaves a lot of Arizona out of play and is a little bit more New Mexico, is sometimes you'll get these real strong fall storms that come out of the northern Rockies and they'll drop down and they'll produce sometimes even like snowstorms in northern New Mexico and on the Great Plains side of Mexico. And so you get backdoor cold fronts, and those will then have moisture from the Gulf of Mexico to interact with. And as those storms kind of progress, what'll happen on the backside of those storms is real cold air on the east side of the Continental Divide will start to try to work its way back towards the west, and that'll actually turn into real strong easterly wind events, and it tends to be dry. It's almost like kind of our version of the Santa Ana. So you can end up having these like really wet, cold storms over New Mexico that are from a low dropping off, and we're actually under a ridge, and those are those kind of easterly backdoor cold fronts. So that would be less for Arizona and much more of a New Mexico type event.
Would there be a PC4? Like, what about just if you shift what you just talked about westward so that you have like a Pacific Northwest trough coming down that sort of goes to the northern, clips the northern part of Arizona, more like a traditional winter storm.
Yeah, I suppose that's right. I suppose that would be more probably more climatological. I would see the thing about the storms that are the more typical progression where you're getting the ones that are just coming straight out of the west. Sometimes they're out of zonal flow where you just
Yeah.
have that kind of flat, not really a ridge, not really a trough. They tend to be much drier and the moisture is typically further north. So you could get into the situation you're getting clouds and a cool down in temperatures, but it's not even yet.
Just a lot of wind.
Yeah, and it's not, and that's the climatological progression, the kind of boring way of getting into winter here, which is then those storms really start to happen more in November, like this time of year. And the northern parts of the states, both Arizona and New Mexico, are starting to pick up snow in the higher elevations, and we're just getting probably wind and maybe brief cool downs. And then it's by late November, you're starting to see kind of the whole Intermountain West start to see their typical winter storm track. So yeah, I think it's probably in there.
But
I was
maybe
thinking,
it's November, maybe it's PC2 in November.
yeah, it could be like if I was
Could
thinking
be
about,
PC1 in November.
yeah, so like if you did this is a horrible abomination of a podcast platform where we're talking about principal components to people,
Well, I
and
think we're talking about the patterns that generate the
yeah,
storms.
yeah. But maybe let's even roll it back and like try to explain to people what we're even talking about. So principal components
It's
analysis
not
are
obvious.
maybe
I'm just kidding. I'm just kidding. Of course,
empirical. So principal components analysis or empirical orthogonal function analysis are it's a statistical geospatial in the climate sense way of breaking down daily weather maps and kind of it's basically taking these daily weather maps and looking for the dominant patterns that would explain variability. So if you had a stack of 100 weather maps, we might say that 30% of them are explained by a pattern that is really an abstraction of all of those weather maps. So it doesn't necessarily give you an actual real weather pattern that is evident in any daily map, but it kind of hints at it. It's like I guess it's what I just said. It's an
right,
abstraction of that.
so the principal component one, if you took those 100 weather maps,
Yeah.
what you
Yeah.
would see, thinking about November, is you'd see a tropical storm low, to the south, and
Yep.
you'd see a low off the west coast, right?
Yep.
So that would
Yeah.
be, whereas what you said, the principal component two, the next pattern in October that is probably common, not as common in principal component one, would just be the tropical storm.
Yeah. Yeah. And remember the way you framed this exercise is you're talking about that bring precipitation. And so in my mind, it wasn't just 100 weather maps. It was 100 weather maps of widespread precipitation across the Southwest, right? So the exercise is already taking widespread rainfall across Arizona and New Mexico, and I'm trying to abstract that into some common patterns that would bring it across the whole Southwest. So, but
When it rains,
yeah,
what does the
yeah,
atmospheric patterns look like?
for sure. But the reason I'm kind of framing it that way is that if you could do this for different parts of the Southwest too. So if you wanted to think about just northern Arizona or northern New Mexico or eastern New Mexico, the stack of weather maps that you'd look at for those pattern abstractions would be different, right? And so then, yeah, so like we kind of changed up the whole thing of like if it's just northern Arizona, then you could see some similar days like we just talked about, but you'd also see this whole other subset of days, which would be kind of boring, normal progression of fall to winter storm track dropping south off of a zonal flow, right?
Right. Um, so is so November would be different though, right? Like, because November you're probably not getting any of the tropical storm assists from, that are moving north from on the East Pack.
Yeah, but it's interesting because I was kind of thinking about this when you kind of framed it up, is that you lose the activity for sure. But in some years, and this is often kind of in El Nino situations, when there is subtropical moisture that's further south, or if you're getting a pretty active storm track across the Pacific, you can, it's not super common in the early part of the fall to winter transition, early part of the winter, you can drag large amounts of subtropical moisture with troughs that drop deep enough and far enough south. You can do you can get a subtropical assist even in November.
Yeah. Is November harder to get rainfall here in the Southwest than October?
That's a really good question. Um, so if you look at the statistics, right, and you probably have these at your hand a little bit more. It's
I have one at my hand.
okay. Well, I'm just trying to, I'm thinking
Yeah.
about so like Southern Arizona, it is, the historical record is wild, right? It's a lot of zeros and then a couple of like crazy large, and it's usually because it's had some interaction with tropical activity. as you go further north in the southwest, the northern parts of the state, um, you're going to get an earlier retreat of the monsoon because the whole dynamics are dropping to the south. So you're going to get into that fall weather. And so that opportunity for northern Arizona to get I think the wild October weather is a little bit less. And as you get into November, the southern part of the Southwest, both southern Arizona and southern New Mexico, are further away now from the winter activity, which is now out of the north. So that's a transition, I think, latitudinally from October to November. So the southern part of the Southwest, both Arizona and New Mexico, it is harder to get precipitation in the southern part of the region, easier in the northern part of the region because the storm track is coming out of the north and the west.
Yeah. So for Tucson, though, would you think that the average of November would be less than the average of October or vice versa?
Um, so average is going to probably be misleading. And probably I would want to know both the average and the variability, quite honestly. I bet October's drier than November.
Yeah, it's well, I think you're right. The average is misleading. I mean, the way that I was thinking about it, well, I'll give the mean for Tucson. So over the period of record, it's about 6/10 of an inch in November and 8/10 of an inch in October. So a little bit lower in November than October for Tucson. But I was
Yeah.
thinking about it just in terms of it seemed like in my simplistic way of thinking about it, like November was shutting off. There was just much less chance for an assist from a northward propagating tropical storm. And
Yeah.
and
Yeah, I think
so
that's right.
and so then you were mainly your main mechanism for generating rainfall was like a low pressure system coming off uh, the the West Coast, or maybe even those backdoor cold fronts, which you said are dry to begin with.
Yes. Yeah. Yeah. And again, this varies across the Southwest too. So it's often in November, we're looking to the north. Flagstaff could get a nice dusting of snow or even a bit of a snowstorm. And the lower elevation and southern parts of the region are just seeing clouds to the north and some wind.
Yeah. Yeah, and I think that's what makes it difficult to talk about the patterns here because they are, pretty different even if you just go in small distances, right? Like New Mexico
Yeah.
has a different flavor than, where we are. So, all right. All right. Anything else about October, November that we didn't hit?
Um, it's so we're November 7th and we are looking on a Friday, November 7th. We're kind of looking forward to we're seeing a La Nina kind of in the works, and we're also just paying attention to the forecast coming up. And what I was kind of surprised with was the week uh the 2 week forecast actually has a pretty strong wet signal coming for the Southwest, and they kind of snuck up out of nowhere again.
Yeah, and I looked at that and are you talking like the 8 to 14 day?
Yep.
Yep. And there's like I think you actually talked about the pattern that is producing this, at least in the models. It's like a low pressure system that's digging down south and that's flinging a bunch of tropical moisture into our region. I
Yeah,
think
it's interesting. This looks
hinting at that.
different. Yeah, it's a little it's like it's almost like we had another reset of a pattern change because what we had earlier in the month was this trough hanging off the west coast, and it really was replaced by a sort of a broad ridge across Southern California and the Southwest, which has pushed us up into above average temperatures, some really quite nice weather for a while now. That pattern is now breaking down, at least in the forecast, and is now having some really strong low pressure systems drop straight south right out of the Gulf of Alaska. And so that's pretty different than what we've seen in the last couple of months. So it's
Mm.
definitely looking a little more fall winter pattern. And they're dropping far enough south that they're able to pick up. They're bringing some moisture with them. The storms are with themselves. They're cold enough that it looks like they're going to be able to be good precipitation generators, and they're picking up some moisture from the south as well.
All right, well, so we'll talk about La Nina in a minute. I thought it's worth sort of summarizing the hurricane season. For the most part, it's over. At least it's over in the Pacific Northwest. Obviously the big news, the big event happened at the end of October, Hurricane Melissa. It was just an absolute monster. This was in the North
Yeah,
Atlantic that formed actually right off south of Jamaica for the most part, but hung out there for a while and it picked up steam. And then it fortunately, I think it took a westward jog. Its track took a westward jog away from like Kingston, the population center. But unfortunately, it still ripped through western Jamaica at like a Category 5, the biggest hurricane this year. And I think it ended up becoming the third strongest hurricane as measured by the low pressure on
yeah,
on record. So
yeah,
pretty devastating situation for Western Jamaica. And then it sort of disintegrated a bit and regained steam as it was moving toward Cuba. Uh, Sort of formed back into a Category 3 when it crossed Cuba and impacted Haiti, Dominican Republic, and Cuba as well. So quite an impactful event. That was the storm on record, I would say, for this summer. Mike, were you paying attention to that one?
it was. I mean, it just the forecasts, just knowing that it was coming was a couple of days out, and just all the signs that were converging as to where it was going to strengthen, and then take that track over Jamaica and then into Cuba was it was hard to kind of sit and watch that. The satellite pictures were stunning. Just how beautiful the storm was and how, at the same time, terribly destructive it was. And just watching some of the Hurricane Hunter videos of them going in and out of the eye were just quite amazing.
Do those videos make you want to be in those planes?
When I was younger, gosh, that was something I really wanted to do. And now that I'm older, no, I'm
But
good.
they're safe, right? They never go down.
They never go down, but I don't think they're comfortable. Yeah.
Well, no, you
I
always see those videos where like they'll go through the eye wall and then like everything will be flying off like
yeah,
desks that are in there as from the
yeah.
computer portals and terminals and stuff like that, which makes me wonder like why the heck aren't they buttoned down, right?
No, I know it is funny. It's like they're surprised that stuff is levitating and flying all over, like the coffee cups and stuff. Yeah, I think it is it's remarkable that you can first engineer a plane that you can repeatedly fly it through turbulence like that. But it's the worst turbulence you could imagine repeatedly. Like and then the only way to get out of the storm. There was an interesting post I saw where it was the one of the Hurricane Hunter planes was in the eye wall and was trying to look for a safe way out and kept trying to look for exit points and was just flying around and around and then finally was able to get up high enough and get out. But just
Yeah, no, that they were remarkable videos and those satellite images, just like the hurricane itself was like the eye wall was so tight and the hurricane was so symmetrical. It was stunning.
yeah, you could see the ocean. You could see the ocean at the bottom, like through the eye, like just how clean and tight and symmetrical was such an indication of the ferocity of the storm on the ground.
So I'll say this because I ended up tuning into a World Meteorological Organization presentation that happened just after it, and they weren't talking about Hurricane Melissa, but they mentioned a few things. One of them was just like how far in advance they had their eyeballs on
Yeah.
the tropical disturbance, like 10 days in advance.
Yep.
They had like good forecast for it. Not exact, but enough for people to start preparing with 7 days. And I think like Cuba had like close to 1 million people, about 700,000 people were evacuated. Jamaica ended up setting up like close to 1,000 emergency shelters. I mean, really, like, I mean, just imagine, 30, 40 years ago when you
Yeah.
didn't have, or even like, I mean, 40 years ago, maybe we were able to see and have some indication of this, for, a couple days, 3 days in advance. But, go back like 100 years when, basically you don't have like an indication of, the impending storm until it's like close enough that you can actually see it or that you can see animals and you get a sense of, birds changing their flying patterns and whatnot, but like much closer in time, So I don't know. I think of this as like just like a modern marvel of like science, right? Like that
Yeah.
we can have like good idea. They're not perfect, but we have a pretty good idea of what's going to happen like up to like 7 days out. And people were talking about, that they thought that this was going to be a really strong hurricane just because obviously the synoptics were going to guide it into a certain area, and that area had like really, really warm water. And so then it was just a matter of, well, does it go like east? Does it go west? Like, and that sort of thing. But yeah, pretty impressive forecasting. Uh,
Yeah, it's remarkable. I was just trying to remember. I read a book a long time ago about the hurricane that struck Galveston in 1900. So, this is well before weather forecasting, and the book was called Isaac's Storm, and it's a really interesting kind of retelling of how people were starting to think about telemetry and using like the telegraph to try to track weather conditions and even take weather observations and share them to have some anticipation of that. But if you can imagine having like not having any warning at all for a storm like that, that is this going to be just a normal rainy day, or is this going to be an actually devastating hurricane? And that was the problem with that storm in Galveston, is that came without warning.
I remember, so I worked for like 5 years in Jamaica. This was like 2015 to 2020. I've tried to get back there to continue to do work. It's been difficult, but I ended up reaching out to people that I worked with a lot, worked with the coffee industry. And I remember doing interviews with farmers for that research. And like the big thing that they would always talk about as so disruptive was the 1988 Hurricane Gilbert that was like the last. I mean, it was also one of the largest, strongest hurricanes on record in the Atlantic, and it also hit Jamaica. And I'm imagining this is just another one of those pivotal points. I mean,
Yeah.
30 years later, people were recalling it as if it was yesterday and how disruptive it was and how, it took decades. In fact, they were still feeling the ramifications of it in the coffee industry. And so I reached out to a couple colleagues who are in Kingston, and they're like, thank God it didn't like come over Kingston. But we got still tons of rain, and the Blue Mountains where all the coffee's grown is in absolute shambles. Like
Mhm.
they were in harvest season. So most of the trees were stripped of everything. So basically their entire crop. And the part of the tragedy is that crop was looking so good.
Oh,
Yeah. Yeah. So just really sad to hear. But guess it comes
yeah.
apart with the territory.
Yeah, and we progressed on the forecasting, but you can't move that coffee plantation out of the way, you know.
Well, that's right. I mean, yeah. And what are you going to do with the crops that people are growing?
Yeah.
You save
Yeah.
lives, and you can
Save
button
lives.
down things, and for the most part. you can button down some things, and yeah, you save,
Yeah,
which
you
obviously
save
is the
lives.
most important thing, but
Yep.
it's they're going to be reeling for a very long time, consequently. So, all right. So I wanted to do summaries of, I got into this to do summaries of the hurricane season. So in the Atlantic, so far, no, this is the Pacific. So basically, the average name storms in the Pacific um, is 15. We've had 18 so far in this season, and so a little bit above average. The forecast was for a little bit above average. Um, And then if you look at sort of more sophisticated indices like the Accumulated Cyclonic Energy Index, which is basically it takes into account intensity and duration. So it's not just naming the number of you know category one, or major category hurricanes. It's accounting for, well, how long did these things persist? It's a better measure. So accumulated cyclonic energy, that's been about average. So basically average at 99.9% of its historical average right now. And in the Atlantic, we've had 13 named storms, and we're slightly above average for total ACE, about 13% above the long-term average for total ACE. Obviously, Melissa had the highest value there. So yeah, it was kind of trying to struggle to get the average number of storms for the Atlantic. I don't know if you have that, Mike. It's less in the
No.
Pacific, so I think it's like 12 or 13. Let me do that
Hmm.
now. 2025 Atlantic. This is riveting um, podcast material. As people are waiting as I Google. Yeah, 14 and a half on average. So we're a little bit below in terms of the number of storms, but above in terms of when you account for the duration and intensity.
Gotcha. Yeah.
Yep. All right. So moving on. Um, like I said in the beginning, we sort of have a lot of pressure on us, I think, for precipitation because we've had back to back to back dry seasons. Doesn't look great, Mike. Looking at the forecast, you mentioned, however, in the short term, 8 to 14 days, like there is sort of an indication for enhanced chances for rainfall. But with a La Nina emerging, and by all accounts, it doesn't look like it's going to be a strong La Nina event. In fact, so if you look at NOAA's most recent models, they have it as a 56% chance of a La Nina and a 42% chance of a neutral event, and only a 2% chance of an El Nino. Basically, it's not going to be an El Nino. So slightly increased chances for a La Nina, and then in that in the La Nina, the highest probability is a weak event. So so that is driving a lot of the seasonal signals. And so largely the seasonal forecasts for the winter are sort of picking up on the classic dry signal in the Southwest and the classic above average signal in the sort of Northwest. Thoughts on the emerging El Nino, La Nina?
Well, it's struggling. It's kind of there-ish. I don't know if it's had a lot of strong coupling with the atmosphere. It looks like it's gonna fight a battle of being able to maintain itself even through into the beginning of the winter. So I think that that's what we've seen with the ENSO quick look forecast is that increase of neutral condition probability rising pretty strongly, pretty quickly. So it could be a short-lived event. So, does that give us any hope that we won't see the strongest of the teleconnections? I think it actually does. We do have that tendency when we see any kind of La Nina signal in the atmosphere that it brings the Southwest into a dry winter situation. But I think that maybe there's a little bit of hope that we're not completely doomed for a typical very dry La Nina winter.
I search for it. NOAAclimate.gov used to have this great article that I sort of bookmarked and would always go to. And it broke out like it had these maps of precipitation, seasonal precipitation for the winter based on the strength of the La Nina event. Can't find that anymore.
Oh man, that's a bummer. Yeah, I
Yeah.
think it's been archived.
Yeah. But yeah, I mean, right, like intensity matters a little bit on this.
It does. I mean, the problem is that intensity, La Ninas tend to, regardless of their strength, drag us into below average winter territory. But yeah, I think you get into a little bit murkier ground when it's a very weak, short-lived event. And especially if it's not mature, it's not making real strong connections with the atmosphere. I think that that'll be something I'm going to, kind of pay attention to.
Well, looking at like the North American multi-model ensemble, I mean, there's a couple models, the NCAR model, actually both NCAR models for oh God, what period is this? January, February, March season. Both NCAR models have a slightly wet signal
Interesting.
for
Yeah.
Arizona. But every other model, like the NASA, the Canadian model, the CFS model has a drier signal.
Yeah.
So it's a little bit of a mixed bag. I think like the probability forecast and putting all of the models together, they're picking up right now on that traditional dry signal that we're
Yeah.
seeing. I'm curious about the international multi-model ensemble. Let's see if I can quickly get that. Nope.
Yeah. I don't think that won't have updated for through last month quite yet. It takes
Okay.
about another week.
Okay. Yeah. I always go to the ECMWF as my go-to. Yeah, it's you're right. So yeah, I guess we'll just have to bear that out. Anything else related to that worth talking about?
No, I'm not. It's been such a weird fall so far with a couple of fairly large rain events for Arizona that and it's oddly timed rain, especially if having kind of poor core monsoon precipitation for a couple summers in a row now. Terribly dry last winter. Strangely wet spring for parts of Arizona. Not as much New Mexico, but eastern New Mexico has had some absolutely wild weather, and New Mexico, a lot of New Mexico actually had a pretty good monsoon. So it's just a strange like we're not all hanging together, and we're getting precipitation kind of in off time seasons. So I kind of feel like just that chaos leaves us open for something interesting this winter. I mean, that's just wish casting at this point, but man, I'll take it.
Well, I like the optimism. What about this? Does the transition pattern matter for like between ENSO phases? So last year, right, we were in like a week La Nina, and then it sort of it always sort of regresses to the mean during the spring and summer. There aren't many analogs actually of us going from like week to week. I look back in
Yeah,
so I couldn't, I think, I look back in the record and there was, 2017, 2018 was one, I think. 2013, 2014 was another one. Um, let's see if I'm right on that. Yeah, I mean, none of them are perfect. Maybe
yeah.
2013 and to 2014 is maybe the closest analog to what's going on right now. But I don't know, does that transition matter at all? Hard to
I
tell.
don't. I mean, I guess the idea that we pay attention to El Nino or La Nina at all is that it has some kind of large scale organizing element to it. That it's got these heating anomalies across the Pacific that start to govern the whole hemisphere circulation. When they're not there, I feel like everything else comes into play, right? So it's going to be like, high latitude, like Arctic oscillation, the Mad Julian oscillation, just the chaos of the weather. So maybe it just leaves opportunity for other interesting stuff to kind of come in and interact with each other.
All right. All right, Mike. Well, with that,
Yeah, I
well,
mean,
let's say
what else there to say? We're out of the monsoon. We're not in winter. There's it's
it's
kind of nice
beautiful
out.
weather. It's
Weather's
beautiful
the
weather.
mosquitoes are still here. I mean,
Not at my house.
really? How'd you do that?
I don't know. It happened in the last couple weeks. Maybe in the
Interesting.
last week, actually. There was weeks when I would go out on my porch and I'd be like, so in my family, and actually out of all my friends, like if I'm around, I'm like a mosquito attractor.
Oh, me too. Yeah.
Like
Me too.
they just swarm me.
Yeah.
And so I'm like super sensitive to it. But yeah, in the last couple, yeah, week to 2 weeks, it's changed. I don't know
I'm
what that.
probably I'm
I
probably
don't know why.
farming.
I thought it was like because the temperatures were dipping a little bit in the mornings.
Yeah, you probably dried out. You probably aren't cultivating them like I am in my yard. Good for you.
All right. Well, we'll come back probably right before the holiday, actually.
Yeah,
Holiday season.
absolutely. That's right.
All right, Mike. Good to see you as always.
Thanks, Zach. Thanks, everyone.
All right.